Nebula. All right, so a nebula, which is Latin for cloud or fog, plural is nebulae, nebulas, is a distinct luminescent part of interstellar medium, which can consist of ionized, neutral, or molecular hydrogen, and also cosmic dust. Nebula are often star-forming regions, such as the pillars of creation in the Eagle Nebula. In these regions, the formation of gas, dust, and other materials clump, air quotes, together to form denser regions which attract further matter and eventually become dense enough to form stars. The remaining material is then thought to form planets and other planetary system objects through accretion or something like that. Let's take a look at a picture. The Trifid Nebula, showing complex gas and plasmic structure, hydrogen gas. That's what it is, according to the first sentence here. Beautiful. I mean, what can you say? It's luminescent, which I think means bright. Emitting light, but not causing heat. Interesting. So it's not causing heat, but emitting light. Most nebulae are vast. Most nebulae are of vast size. Some are hundreds of light years in diameter. A nebula that is visible to the human eye from Earth would appear larger, but no brighter from close by. The Orion Nebula, the brightest nebula in the sky, and occupying an area twice the angular diameter of the full moon, can be viewed with the naked eye, but was missed by early astronomers. Although denser than the space surrounding them, most nebulae are far less dense than any vacuum created on Earth. They're less dense than any vacuum. Oh my gosh, that's insane. Like a vacuum on Earth, what we consider a vacuum, nebula are less dense than that. 10 to the 5th to 10 to the 7th molecules per cubic centimeter. Seems like a lot, but apparently that's nothing. A nebula cloud the size of the Earth would have a total mass of only a few kilograms. Are you guys getting this? That's insane. It's insanely, it would be the opposite of the word dense. I don't know. Airy, or maybe, I don't know. Earth's air has a density of approximately 10 to the 19 molecules. So this is, 19 minus 5. It's like 13 orders of magnitude less. So Earth's air has a density of approximately 10 to the 19 molecules per cubic centimeters. By contrast, the densest nebula can have densities of 10 to the 4 molecules per cubic centimeter. Many nebulae are visible due to fluorescence caused by embedded hot stars, while others are so diffused that they can be detected only by long exposure in special filters. Some nebulae are variably illuminated by T-Tauri variable stars, which are its own thing that I've never in my life heard about. Gosh. Okay. Last paragraph. Originally, the term nebula was used to describe any diffused astronomical object, including galaxies, beyond the Milky Way. The Andromeda galaxy, for instance, was once referred to as the Andromeda Nebula, and spiral galaxies in general as spiral nebulae. Before the true nature of galaxies was confirmed in the early 20th century, that is, the early 1900s, by Vestosifer and Edwin Hubble. I've heard of Edwin Hubble. Hubble Space Telescope. I haven't heard of Vestosifer. Never heard of this dude. And others. So Edwin Hubble discovered that most nebulae are associated with stars and illuminated by starlight. He also helped categorize nebula based on the type of light spectra they produced. All right, so it's a luminescent part. It's a distinct luminescent part of interstellar medium, which consists of ionized, neutral, or molecular hydrogen and cosmic dust. So we have dust and hydrogen, either ionized, neutral, or molecular. The stars that are embedded create light. It's not luminescence because it's creating heat as well, but that light is, I guess, radiating off of all of the ionized hydrogen and the dust material, and that's what give it colors and makes it seem like it has light. I don't know. There's a lot of different types. Okay, so we have classical types. These are wait. Very cool pictures, by the way. I'm just looking at them right now. Cat's eye, all kinds of different kinds. Wow, look at that. Jeez. So classical types, flux types, diffuse types, planetary types, which are where does it say? Planetary are final stage of stellar evolution for mid-stars. Interesting. I thought the final stage was a supernova. Is that what happens after a supernova? I don't know. I guess I could open this if I want. We also have supernova remnants. There we go. So supernova occurs when a high mass star reaches the end of its life, its last evolutionary stage. When nuclear fusion in the core of the star stops, the star collapses. The gas falling inwards either rebounds or gets so strongly heated that it expands outwards from the core, thus causing the star to explode, not implode. The expanding shell of gas forms a supernova remnant, a special diffuse nebula. Got it. That was too easy. Although much of the optical and X-ray emissions from supernova remnants originates from ionized gas, a great amount of the radio emission is a form of non-thermal emission called synchrotron emission. Okay. A lot to unpack here. Amazing pictures in this article. Look at that thing. Wow. Ring Nebula. Whoa, it's like the Eye of Sauron. Oh my gosh. Supernova remnant in X-ray light. How freaking cool. All right, so that's it for this one. Hope you wonderful people enjoyed it. I learned something.